Many of you will wonder what the clinical applications are of the Stewart approach to acid-base. And I think there are two answers here. The first answer is that it does give you a bit of the maths. It gives you a much more reasoned approach to actually working out what happens. We know, for example, from our exploration of the Stewart approach, that if you change the amount of weak acid, the amount of albumin and phosphate in plasma, that things are going to happen to the pH, and things are going to happen to the bicarbonate concentration, because everything is intertwined. But there's a second, much more subtle and to me much more important thing that you've learnt, and that is you've gained an approach to the overall understanding of how acid-base works. The conventional approach doesn't actually give you that understanding. By playing with the numbers, by playing with the equations, you've gained a certain degree of mastery over the whole system. You understand it at a much deeper level. And I think this is actually what is really valuable. Let's take a practical example. If you take a patient who is very sick and who's lost a lot of blood, and you give them a large amount of normal saline, what is going to happen to the pH of their plasma? The conventional approach doesn't give you an adequate answer. But if you use the Stewart approach, things become quite simple. We know that the strong iron difference of normal human plasma is about 42. We also know that normal saline has about 154 millimoles or milliequivalents of sodium and an equal amount of chloride. So the strong iron difference is 0. Let's take a simple example where we replace half of the human plasma with normal saline. What is going to happen to the pH? Well, the strong iron difference will drop from 42 to 21. It'll drop in half. And we know from the Stewart approach that there'll be a corresponding decline in the pH. So if I give large amounts of normal saline to a sick person, I'm going to drop their pH. And this is actually what we find when this has been looked at experimentally. If I drop the pH, the chances are that that patient is going to become more unwell and more difficult to resuscitate due to the associated vasodilatation. This is a good practical example where a little understanding goes a long way and may actually help us clinically, even if we don't actually sit down and do the maths. But you can now do the maths as well, because you understand how the computer program works, and you've learned a lot in this regard.